Hi everyone, today we will look another part of chapter 8, measures of dispersion for ungrouped data, that is effect of data changes on dispersion. So now we will look what is the effect of data changes on dispersion. You can refer your textbook at page 228. The data changes include the following cases. Each data is added or subtracted by a constant uniformly. Each data is multiplied or divided by a constant uniformly. The existence of outliers or extreme values in the set of data. Certain values are removed from the set of data or added into the set of data. There are no changes to the measures of dispersion when each value of a set of data is added or subtracted by a constant. When each value of a set of data is multiplied by a constant k, then new range will be k times original range. New interquartile range will be k times original interquartile range. New standard deviation equal to k times original standard deviation. New variance will be equal to k square times original variance. When each value of a set of data is divided by a constant k, then new range will be equal to original range divisible by k. New interquartile range will be equal to original interquartile range divisible by k. New standard deviation will be equal to original standard deviation divisible by k, and new variance will be equal to original variance divisible by k square. So what are the effects on the measures of dispersion when outlier is added or removed from the set of data? Range. The range will be changed dramatically when an outlier is added or removed from the set of data. Interquartile range. The interquartile range is less affected when an outlier is added or removed from the set of data. Variance and standard deviation. The variance and standard deviation will increase significantly when an outlier is added into the set of data. If the difference between the new value of the data and the mean is small, then the new standard deviation will be smaller and vice versa. If the difference between the value that is removed and the mean is small, then the new standard deviation will be larger and vice versa. So now we look some example. So here the first, the data is changed uniformly by adding or subtracting a constant. So this is score in science quiz. So given the score from 8 until 15. So score 8, there are one pupil who achieved score 8. Score 9, got 3 pupils achieve score 9. Score 10, so 3 pupils achieve score 10. Score 11, 5 pupils achieve score 11. 12, 4 pupils achieve score 12. 13, 2 pupils achieve score 13, and 1 pupil achieve score 14 and 15 respectively. So when each value of a set of data is added by 2, that means score 8 now, just now the pupil who gets score 8, we add the score 2. We add 2 to the score. So when 8 plus 2 becomes 10. So 8 becomes 10. 9 becomes 11. 10 becomes 12. 11 becomes 13 and so on. So the range here from just now from 8 to 15 now change to 10 to 17. In the above diagram, when each value of a set of data is added by 2, it is found that the whole dot plot is shifted to the right by 2 units where the dispersion remains unchanged. So the original score range is the largest score 15 minus the smallest score 8 is equal to 7. And the new score range also the largest score is 17 minus the smallest score 10 is also 7. So in this case, the range of both sets of data is the same. In general, when each value of a set of data is added by a constant, the measure of dispersion remains unchanged. Next, we look the data is changed uniformly by multiplying or dividing by a constant. So given here dot plot of score in mathematics quiz. So score 1. So one pupil achieve score 1. 3 pupils achieve score 2. 5 pupils achieve score 3. 4 pupils achieve score 4 and 3 pupils achieve score 5. Now, when each value of a set of data is multiplied by 2, that means the score just now we multiply by 2. Score 1, 1 multiplied by 2, we get 2. 2 multiplied by 2 got 4. Here 3 got 5 pupils. Multiply by 2, so you get 6. Score 6, 5 pupils. 4 got 4 pupils, so 4 multiplied by 2, you get 8. 8 got 4 pupils. 5 here got 3 pupils, so 5 multiplied by 2 got 10. So 10 here got 3 pupils. So in this diagram, when each value of a set of data is multiplied by 2, it is found that the dispersion of the whole dot plot becomes twice as wide. That means the original score range, okay, the largest score 5 minus 1 is 4. But now the new score range, the largest score is 10 minus the smallest score 2. That is 8. So the range of the new set of data is 2 times of the range of the original set of data. So when the score is multiplied or the set of data is multiplied by 2, the range also we multiply by 2. That means the original 4 we multiply by 2, you get the new score range is 8. So when each value of a set of data is multiplied by a constant k, new range will be equal to k multiplied original range. In general, when each value of a set of data is multiplied by a constant k, the measures of dispersion will change. Next, we look when the value added or removed in an outlier. Outlier is something that is the score or the number is different, have quite a big difference with the other scores. So here score in mathematics quiz from 1 to 5, like just now, example just now. Now we add an outlier, 9 is added. So suddenly there is a one pupil who score 9, okay, who achieve score 9. So when an outlier, there is an outlier added in this set of data, it is found that the dispersion of the whole dot plot becomes wider. Just now, the original score range is the largest score 5 minus 1, 4. Now when an outlier 9 is added, So the new score range, the largest score now is 9 minus the smaller score is 1, that is 9 minus 1, 8. The range of the new set of data becomes larger compared to the range of the original set of data when an outlier is added. In general, the measure of dispersion of the new set of data become larger compared to the measures of dispersion of the original set of data when an outlier is added. So for better understanding, we look at example 13. You can refer your textbook at page 233. Given a set of data 4, 6, 7, 7, 9, 11, 12, 12, calculate the standard deviation of the set of data, hence calculate the new standard deviation when 4 is removed. That means from this data, you are going to remove 4. So when you remove 4, okay, you will left 6, 7, 7, 9, 11, 12, and 12. Okay, so first we calculate the standard deviation of this set of data. So in order to calculate the standard deviation, first step, I hope you all still remember, you have to calculate the mean. So how to calculate the mean? You plus all the value of the data, 4 plus 6 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12 divide by 8. 8 is the number of data. That means you have 8 digits here. So you will get 8.5. Then use the formula, find the sum of squares first. 4 square plus 6 square plus 7 square plus 7 square plus 9 square plus 11 square plus 12 square plus 12 square divisible by the number of the data, that is total 8 data, minus mean square. This is the formula for standard deviation. Then you square root. So you will get 2.784. So now when 4 is removed, your new mean will become 6 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12 divisible by 7. So 9.143. And your new standard deviation, also same, use the formula. You find the sum of square first, 6 square plus 7 square plus 7 square plus 9 square plus 11 square 12 plus 12 square plus 12 square divisible by 7 because you already removed 4, one data, minus mean square, so you get 2.356. So when the value that has a greater difference from the mean is removed, the new standard deviation will be smaller. That means just now you remove 4, and 4, the difference between 4 and 9.143, your mean is got a greater difference. Okay, the differences between 4 and 9.143 is quite big. So the new standard deviation will become smaller. Okay, if the difference is greater, the new standard deviation become smaller. Next, when 7 is added. Okay, 7 is added, that means you plus another 7 lah. Okay, 4 plus 6 plus 7 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12 divisible by 9. Now your mean is 8.333. And standard deviation, 4 square plus 6 square plus 7 square. You find the sum of square divisible by 9 minus mean square. So your standard deviation is 2.668. So when the value that is close to the mean is added, so your mean is 8.333 and you add 7. 7 is nearly a bit close to 8. So the new standard deviation will smaller. also become smaller. Okay, next we look part C. 18 is added. Just now 7. Now 18 is added. You add 18. So your new mean is 9.556. That means 18 and 9.556 is got a greater difference. Okay, got quite big difference. Then you find the sum of square divisible by 9. Now why you divide by 9? Because you have add one data, add one value, 18. Okay, that's why got 9. Original got 8 values, now got 9 values. Minus mean square, so you get the standard deviation is 3.974. So when the value that has a greater difference from mean is added, the new standard deviation will be larger. Okay, so the difference is quite a lot. Okay, so the new standard deviation become larger. So I hope you understand this subtopic. So thank you for watching.